And I believe he presents them in this order for a reason. And that reason is if else are pretty simple and intuitive, I would say. On the other hand, while statements and even for loops can be less obvious, less intuitive, but I would argue they are more powerful. Again, you're just working with strings, but you're going to use these, what are often called repetition structures, very often. Okay, so the general syntax is this for the while statement. Again, while operates on Boolean conditions, right? So in this Boolean, it's going to evaluate this to be true or false. And it will only execute if it's true. Okay, so the way while works, this has to be true in order for the statements in the block, in the while loop to run. And again, don't forget about that pesky old colon. You've got to put the colon there, and you have to indent the statements in this manner. Okay, so again, while is an example of an iteration structure, which provides a way to repeatedly execute a block of statements. So sometimes it's also called an iteration structure or repetition structure. Repetition structures are implemented with both while and for loops, as we'll see. So this, again, here's the general syntax. Starts with a while keyword, following by a Boolean expression, and then a colon. And then an indented block of one or more statements starts on the next line. These are the statements that are in the loop, and they end when the indentation ends. Okay, when Python executes a while statement, it executes the statements in the loop while the Boolean expression evaluates to true. So as long as this expression, whatever it is, evaluates to true, it's going to go round and round and through these statements again and again and again. The only way, well, there's a couple of ways you can get out of it, but one way to get out of the while loop is you have to force this thing to turn false if some condition is met. You can also use break statements. Break will is like pass in an if. Break will cause the while loop to end. And then there are continue statements, which will cause the while loop to start over again. Okay, so this is our first example. This is significant in that it shows you how to make things run over and over and over again, right? So we initialize choice to be a string, a lowercase y. And then while this string is a lowercase y, it prints hello. And then it goes and asks for input. Do you want to repeat this? Say hello again. Notice that if the person enters yes, choice again becomes, this becomes true. So if the person enters a lowercase y or an uppercase y, this Boolean condition is choice.lower equal to a lowercase y will always be true. So we'll just keep on going through this over and over again until they enter anything other than an uppercase y or a lowercase y. Okay, so let's take a look at this. And this is script 28. And we got plenty left. Okay, so and I've documented it. So what can go wrong? Well, besides you getting bored by it repeating hello again and again and again, what happens if we enter in something invalid data like that? It shouldn't have done anything, but it did. Notice that it was asking for yes or no, and I didn't enter either of those. But actually, the way the program is written, it's only checking to see if it's yes. If anything other than yes, an uppercase y or lowercase y, is entered, choice is going to change values, and therefore this is going to be false. Okay, so you ought to check that. A good program would say, no, Mr. Ubona, you can't enter an uppercase X. You've got to enter a Y or an N. Okay, so, and we'll get to that. Okay, so this is a good way in your program coming up in your exercise for next week, if you get around to it. This is a general template for giving the user the option to continue. And the way you would do this in your program is you would set this up just after you initialize your variables, right? And we'll look at this, right? So you do a while loop at the very top of the program, and just after you initialize all your variables, that whatever variables are manipulated in the program. Notice they do that here. You do initialize choice to a string, lowercase y. It's always good practice to do that, in my opinion. You don't always have to. You can create variables on the fly inside of these control or iteration statements. And they, unless you're trying to do a calculation with something that hasn't been defined, it usually will run just fine. But just for clarity, anything that you're going to manipulate in your program, it's a good idea to set them equal to some value at the top. If they're numeric, probably 0, just to avoid possible issues. You'll notice often in some of the programs we'll see even today, if you enter certain values, it blows up and you get some sort of arcane message about trying to divide by 0. And usually that's caused by the denominator not being defined at all, as we'll see. So you can avoid that if anything you're going to use in a calculation, you give it some sort of value, which makes sense in the context of your program before you start doing all of these looping things. Okay. So again, this is a repetition structure. Let's see what we're doing here. Got some time. Okay, so let's, one thing I like about Merak is he starts off slow and then builds on it. Okay, so this again is a simple program. We're using a while loop to run through the digits, the counters. You're going to need to use counter. You're going to have, I believe, at least 2 counters. If I remember correctly, the exercise for today, you modify the test score program such that you keep score, you keep account of the number of valid entries that are entered, as well as the number of invalid entries. So that's what counters do. You typically will insert a counter in a loop, either a for loop or a while loop, to keep track of how many times it's gone through it. Okay. So while you could call this variable anything you want, number, num, it's a good idea to give variables names that will remind you what it's doing. And counter variable is counting. Okay. So since we start out at 0, this is going to be true, right? And it's going to simply print the value. Notice that even if let's try this with and without, let's run this. I'm curious about whether it will run without initializing. And this looks just like the slide. notice we're using what I call an incremental assignment. It's going to add 1 to counter. So we set counter to 0. The first time it gets to this point, counter is going to be 1, which means this is still true. 1 is less than 5, so it'll go through it again. Second time it gets here, counter is going to be 2, so it's true, so it'll go through this again. And it should repeat while counter is 0, 1, 2, 3, and 4, and just simply print out the value of that. Let's see if it does. Right, that's all it does, 0, 1, 2, 3, and 4. But let's, if we comment out that first line, here, yeah, this is not going to work. This is a prime example of why you should initialize it. It won't know what counter is when it gets to this while loop. So we should get a runtime error. And sure enough, we do. Okay, can't find the variable. Okay, so that's a good example why anything that you manipulate inside the loop should be initialized before the loop. And typically in your program, for example, the exercise for the end of today, you'll have 4 or probably 5 different variables that you're manipulating inside of nested while and if statements. So you want to stack them up at the beginning of the program, initialize them all to 0. If they're numeric, of course. Okay. So finally, when counter does actually it would be the 6th loop, right? Because it starts at 0. In this case, it's starting at 0 because you told it to, because you said, well, counter equals 0, do it until do it while counter is still less than 5. So down here, when it goes through it on the 6th try, I believe counter was going to be, no, on the 5th try, no, on the 6th try, 0, 1, 2, 3, 4, that's 5. When counter turns into 5, this is going to be false. So it just stops. And okay. This is a common, instead of messing around with variables, you can what I would call hardwire a while loop to just keep running forever. And this works. Note that uppercase T, R, U, and E is a reserved word. It means the value of this is true. It's always true. Okay, so if you use this technique, it will force the loop to run forever unless you do something within the loop itself that causes it to terminate. One thing you can do is to put a break clause in there. Break, I believe, will end the loop and force it out. Okay, so we'll see some examples of why you would want to do this. If you do end up in this nasty situation where where idle just seems to be doing nothing, running forever, you can get out of it on a Windows machine by holding down the control key and pushing the letter C on your keyboard, or in a Mac, you can hold down the command key and simultaneously press a C. Okay, so that will cause the program will be executing over and over and over again, but that will cause it to stop, to terminate. Okay, and this is an infinite loop, and it's not hard to get into an infinite loop. So that's how you get out of it. Okay, you can also, as I mentioned, you can use a break statement to get out of it.